All right, today we're diving into how AI is learning to have its own aha moments. Those flashes of insight that drive real discovery. There's this new project from Google Research called Mars, and it's basically teaching AI to stop just being a coder and start acting like a genuine research scientist. We're talking managing budgets, learning from failure, the whole shebang. And really, it all comes down to this one big question, right? Can an AI actually learn to think like a scientist? I don't just mean spitting out code. I mean, can it strategize? Can it learn from its mistakes? Can it manage its resources and have those breakthrough insights that really push science forward? Okay, so to really get why this is such a big deal, we have to look at the core problem. Why is automating AI research so much tougher than just, automating regular software development? It turns out there's a huge roadblock. And this slide really gets to the heart of it. See, standard coding is pretty straightforward. It's often black and white. Either the code works or it doesn't. You can test it fast. But AI research, oh man, that's a totally different beast. The paper calls it a probabilistic resource-intensive endeavor, which is a fancy way of saying it's messy and expensive. You can literally spend days training a model just to get a teeny tiny improvement, and half the time you don't even know for sure what you did that made the difference. And because of that messiness, most AI agents right now are, well, they're pretty terrible researchers. They fail in three major ways. First, they totally ignore budgets. They'll just burn through time and compute power for the smallest gains. Second, they write this awful tangled code that's impossible to debug or reuse. And the biggest one, they have what's called the credit assignment problem. Basically, they can't figure out which of their ideas actually worked and which were duds. And if you can't learn from experience, you're not going to get very far. So to tackle all these problems, the researchers at Google came up with a completely new kind of agent. So let's meet our hero, Mars, the AI that's built to be a smart scientist. Now, this new framework from Google Cloud AI Research isn't just another bot that writes code. No, this was designed from the ground up, specifically to get over those exact hurdles we just talked about. And its name, Mars, basically tells you everything you need to know about its secret sauce. It stands for Modular Agent with Reflective Search. And trust me, each of those words is a hint at one of its superpowers. Let's break that down. You can think of Mars's whole scientific approach as being built on three main pillars. And it's these three things working together that let it act less like a dumb script and more like a seasoned researcher. Okay, pillar number one is budget-aware planning. So unlike other agents that will just chase after a 0.1% improvement no matter how much it costs, Mars is, well, it's thrifty. It gets that a model that takes 10 hours to train might be useless in the real world compared to one that's almost as good but only takes an hour. It's constantly doing that cost-benefit analysis. Next up, pillar two, modular construction. Remember that spaghetti code we talked about? Well, Mars doesn't do that. It acts like a professional software engineer. It designs a solution, breaks it down into clean, separate, testable pieces. This makes everything it builds way more robust, way easier to fix, and way easier to improve later on. And the third pillar, which might just be the most important one, is what they call comparative reflective memory. This is its secret weapon for solving that credit assignment problem. Think of it like a super detailed lab notebook. It's constantly comparing experiments, looking at the differences, and figuring out exactly what caused a result to get better or worse. It learns real lessons from both its successes and its failures. Okay, so with these three pillars in place, how does Mars actually do in the real world? Well, the researchers threw it into the deep end, a bunch of really tough machine learning competitions. And this is where we see its aha moment. Just look at this. It gives you a sense of how insanely complex this whole process is. Every little circle here is basically a different experiment. Mars is navigating this giant maze of possibilities, testing out different kinds of networks, fiddling with learning rates, you name it. And it's learning something from every single try. And then this happens. This is the aha moment. After trying tons of different things, Mars has a breakthrough. It takes a lesson it learned from one branch that totally failed, combines it with an idea from a completely different branch over here, and puts them together to create this new winning plan. That's exactly how human scientists make discoveries, right? By connecting ideas that nobody thought to connect before. And the results of that brilliant new plan? A final score of 0.656. Now, for anyone who knows the super competitive world of Kaggle competitions, you know that's a fantastic score. And it was good enough to earn Mars a silver medal, a real, tangible prize for its scientific process. So, how does Mars actually stack up against other top AI agents out there? Well, in a controlled head-to-head competition, the results are pretty staggering. Mars won a medal 56% of the time. That's a massive leap over its rivals. And it snagged a gold medal almost a third of the time.
I mean, this chart really says it all. When you put them all in the same environment with the same rules and resources, Mars isn't just a little bit better, it's playing in a completely different league compared to the other top agents.
And this success isn't just down to one magic feature. The researchers proved it by basically turning off its superpowers one by one to see what would happen. In these charts, that top green line is the full Mars system, firing on all cylinders. The other lines, that's what happens when you take away its organized coding, or its memory, or its budget awareness. Performance just tanks. It proves that all three pillars are absolutely crucial. So, what does all this mean? Why is this such a potential game changer for AI? I think this quote from the paper just nails it. Mars isn't trying to write a single, perfect script. It's trying to build an optimal software repository. It's thinking like an engineer building a library of tools, not just a one-off program. It's a much more structured and professional way to think about research. So, what are the big takeaways here? Well, for me, there are three. First, AI is really starting to evolve from just being a coder to being a partner that can actually plan and strategize. Second, Mars is so good because it copies the habits of the best human researchers. It's efficient, it's organized, and it learns from everything. And finally, this is way bigger than just winning coding competitions. Imagine applying this kind of scientific engine to things like medicine or discovering new materials. The potential is huge. And that really leaves us with a pretty mind-blowing question to think about. If an AI can truly master the scientific method and become a world-class researcher, what's the next great discovery it's going to unlock for us?